Alright guys, in previous video you saw how I did factoring a monomial from a polynomial. So that's basically I had something like two terms, and we were able to find the GCF for these two terms, and previous video explained the details of this. So we see that the GCF here was 16 for the constant factor, and for the variable factor it was x squared. And to find our remaining factor, we use the GCF as a divisor in the original expression, and we will get our remaining factor. Forgive me if the enthusiasm in my voice has died down. It's because I am tired, but I really want to get this out the way for you guys. So here we have remaining factors as x, and this one was just 2, x plus 2. So this here was a factoring a monomial from a polynomial. So now the next stage of factoring, we're going to do factoring from by grouping. So you see, in this first example, we had two terms. In order to factor by grouping, you will see expressions that have four terms, as in this case. Here we go. So we're going to use that example. That was 6m cubed minus 2m squared plus 9m minus 3. So here's how factoring by grouping works. We have four terms, and we're going to create two groups before we begin factoring, right? So we're going to first start by creating two groups. And just by default, we usually take the first term, the first two terms, and group them plus the last two terms. Now, notice now we went from a four-term expression to a two-term expression. What you do here now, just like how we handle this two-term expression in our first step, in our first introduction to factoring, we're going to do the same thing here. So what we're going to do here is that we're going to factor each group individually. I don't know if that's redundant, but you get the point. So we're going to next, so after we create our two groups, you're going to factor each group independently. Good. So if we look at our first group of terms, what do we see common? What do we see as a GCF in 6m cubed minus 2m squared? We see that for the constant factor, they have a greatest common factor of 2. And for the variable factors, we'll take the lowest power. So that's m squared. So the GCF for the first group is 2m squared. And what's our remaining factor? Remember how we find our remaining factor? We find it by taking our GCF and using it as a divisor in our original expression. I feel my zeal coming back. Good. So here we go. The remaining factor for the first term would be 3m, because 2 divided 6 is 3. M cubed minus m squared is m1, minus the 2's cancel and the m cancel. So anytime we're dividing factors of the same base and same constants, we have a remaining factor of 1. Okay, so that's my first group of terms that I factored. Then I'm going to go now to my second group, which is 9m minus 3. And if we look at these two terms, they have a common factor of 3. Their GCF is 3, but they do not have the same variable factor because we have a 9m term and we just have a constant term. So what we're going to do, we're going to divide our GCF for this group into the original expression. So we're left with 3. 9 divided 3 is 3. So we're left with 3m. And 3 divided 3 is 1. So here is how you know you're on the right track. When you're finished factoring individual groups, you should end up with an expression, right, that has the same, another factor to factor out. another GCF. So if we look at this, this is actually two terms. Remember, a parentheses turns many terms into a factor, right? So this is actually 2m squared times the quantity 3m minus 1. So this is one term by itself. And this is 3 times the quantity 3m minus 1. So this is another term by itself. So technically, we have created this 4-term expression into a 2-term expression. And when we look at two terms, as in the case of 16x cubed plus 32x cubed, we can look for a GCF in any 2-term expression. And when you look at these 2-term expression, can you see them having a common factor? Great, I know you could have. So I'm not going to depend on you to recognize that. So here we have the factor 3m minus 1 as common in both terms. And the reason why we can call these terms factors is because they're in parentheses. If you remember in my introduction to this course, that I identify one of the functions of a parentheses is converting terms into factors. So now my GCF for this expression now is 3m minus 1. Right? And what do we do with GCFs? We take the GCF and we divide it into the original expression. Now, when you become an expert at this, you will have hindsight to this. You won't have to do this step. I'm just showing you the details so you could know where your solution is coming from or how it came about. All right? So here we go. Cancel out, cancel out. And what am I left with? What's my remaining factor? 2m squared plus 3. So that's factoring by grouping. Let's do one more example for the road. Here we go. Good. So here we have another example of a 4-term expression. And remember, when we have 4-term expressions to factor, we factor by grouping. So the first thing I'm going to do is going to create my 2 groups. So using my first and my first 2 terms and then my last 2 terms. So this is actually 12 x cubed minus 3x squared minus, I'm going to take the sign of the third term, right? And I'm going to group my last 2 terms. But here's a caveat. So you see here was a plus 2. It was a plus 2 when it was by itself. But now that it's become a factor, I'm going to have to change the sign to a minus 2. And let me explain why that happens. Because this negative is actually saying take the opposite of everything that's in the parentheses. So those distributive principles still applies, right? This is how we connect everything that we learn in our foundation course, in our foundation topics, right? So the reason why the sign have to change in this parentheses is because now we have a negative outside this factor. So this is saying the opposite of positive 8 is negative 8, as you see in the original expression. And the opposite of negative 2 is positive 2. So just remember, this is definitely an expression you would see on an exam. This is definitely an exam question. I guarantee you. You will have an expression where when you group it, the minus will be outside. Please remember to change the sign. It's saying to take the opposite of the terms inside the parentheses. Also, you have to be very careful. If you have your 2 terms that are in factored form and they have opposite signs, something is wrong. The signs here must be the same. Good. So now that we've established that, now we're going to factor our individual groups. So I'll factor my first group. And now that you know the process, we could just cut to the chase and go straight to it. So here we go. What's common between 12 and 3? 3. That's correct. And now we're going to take the lowest power between x cubed and x squared. We're going to take x squared. Right? And by hindsight, we can actually just perform our division right here. We don't actually have to physically write this once you understand where it came from. So here we go. We have 12 divided by 3, we know is 4. And x cubed minus x squared is x1 or x. Minus 3 divide 3 cancels out. X squared divide x squared cancels out. So you have 2 factors here that are the same. 3x squared divided by 3x squared. Anything divided by itself, leave a factor of 1. What do we have common here? Obviously 2. There are no common x variables because only one term has x. So we're left with 8 divided 2 is 4x. 2 divided 2 is 1. Here we go. So now we look at our new two-term expression and we see that it has a common factor of 4x minus 1. You know you're on the right track once you develop these common factors after you factor the individual expressions. Here we go. So my GCF here is 4x minus 1. And my remaining factor in hindsight, if I divide my GCF by the original expression, we see they cancel. You will be left with 3x squared minus 2. All right. So just one more example. Sometimes you will see an expression that's already in this form. So for example, in your text here, you have one of the first question. Actually, this is not a 4-term expression, so you don't have to do grouping. They already did the work for you. This is a 2-term expression. They've already presented this problem to you in the 3rd step. You see, that's the original expression. That's the 2nd step. 3rd step, they present it to you like that already. So if we have a problem like number 1 from your text, that is x times a plus b plus 3 times a plus b, right? You see, obviously it's not 4 terms, it's just 2, 1, 2. Remember, terms are separated by plus or minuses. These are not terms. These two are factors because of that parentheses. And when we look at this expression, what do we see it has as a GCF or a common factor? That's right, a plus b. And the remaining factor is x plus 3. Great, guys. So that's factoring by grouping. And you know how to find me if you have any questions or if you need any type of clarification. Good night.